This is day 7 of Advent of Cyber, and the challenge is called Maldocs Roasting on an Open Fire. So let's go to TryHackMe and let's get started. In the previous task, we learned that Mixkitty was indeed a victim of spearphishing campaign that also contained a suspicious looking document. Mixkitty accidentally opened the document, and it's still unknown what this document did in the background. Mixkitty has called out the in-house expert, Forensic McBlue, to examine the malicious document and find the domains it redirects to. Malicious documents may contain a suspicious command to get executed when opened, an embedded malware as a dropper, or may have some C2 domains to connect to. So the learning objectives for this challenge are you'll learn what CyberChef is, the capabilities of CyberChef, how to leverage CyberChef to analyze a malicious document, and how to deobfuscate, filter, and parse the data. So for this challenge we need to deploy the machine, which I have already done. So CyberChef. CyberChef is a web application used to slice, dice, encode, decode, parse, and analyze data or files. The CyberChef layout is explained below. An offline version of CyberChef is bookmarked in Firefox on the machine attached to this task. So in this panel over here, you add the text or file. Panel 2 has a variety of different functions that you can run on the input. So you drag the function here into the recipe panel here, and this will run on the input and will display in the output area here. So to actually run it, you then click the button on the bottom here. So using CyberChef for maldoc analysis. Let's utilize the functions, also known as recipes, from the left panel in CyberChef to analyze a malicious doc. Each step is explained below. So you can go to CyberChef and drag a file into the input panel. This will then load the file to there. You can extract strings with the strings function here. So you search for it, you click and drag it into the recipe, and you can change the match to all printable characters. So when you run this recipe, you can examine the results. So we can see random strings of different lengths and some obfuscated strings. So you can narrow down the search to show you the strings with a larger length, and you can keep increasing the minimum length until you remove all the noise and are only left with a meaningful string as shown below. So in this output there is a pattern here of bracket _ bracket. So to obfuscate values, attackers often add random characters. So for example, we can find some repeated characters, which was stated before, and these characters are common in different places. We can use regex with the find and replace function to find these bracket _ brackets and remove them. So to use regex, we'll put the characters within the square brackets and use \backslash to escape the characters. In this case, the regex will look like bracket / bracket / bracket / n _ bracket, where /n represents the line feed as shown below. So you search for the find and replace recipe, you place the recipe into the recipe panel, and when you run this, you can see the output that's here, and it's running some kind of command. It's evident from the result that we are dealing with PowerShell script, and it is using base64 encoded string to hide the actual code. Drop bytes. To get access to the base64 string, we need to remove the extra bytes from the top. Let's use the drop bytes function and keep increasing the number until the top bytes are removed. Search for drop bytes, drag it to the recipe area, increase the length, and now you're left with only the base64 text. So with this, you can now decode the base64 using the base64 recipe. So you grab that, drag it below, and it will decode it. So decode UTF-16. The base64 decoded result clearly indicates a PowerShell script, which seems like an interesting finding. In general, PowerShell scripts use the Unicode UTF-16LE encoding by default. We will be using the decode text function to decode the result into UTF-16E as shown below. So you search for decode text, you specify the encoding type you want to decode to, and in the output here we can clearly see that it's commands being run. So find and remove common patterns. Forensic McBlue observes various repeated characters, such as these, within the output, which makes the result a bit messy. So regex can be used to find and replace those characters with the following regex, and then when you run that, we can see that the PowerShell script is much more clear as compared to what it was like here. So if you examine the output, we'll find various domains and some weird letters. Bracket B2H _ before each domain reference. A replace function is also found below that seems to replace this string with HTTP. So find and replace that with HTTP, then extract URLs. The result clearly shows some domains, which is what we expected to find. We will use the extract URLs function to extract the URLs from the result as shown below. So extract URLs, drag it here, and output is the URL that was within it. So split URLs with @ The result shows that each domain is followed by the character, which can be removed using the split function as below. So split function, the delimiter is the @ symbol, and you want to replace that with a new line. So now each line of the output is the individual URLs. So defining URLs. So we have finally extracted the URLs from the malicious document, but it looks like the document was indeed malicious and was downloading a malicious program from a suspicious domain. Before passing the domains to the SOC team for deep malware analysis, it is recommended to defang them to avoid accidental clicks. So defanging URLs makes them unclickable. We will use the defang URL operation to do this task, and as you can see, it's replacing the HTTPS with HXXPS, and it also surrounds the dot with brackets. So with this format, the URLs won't come up as clickable. So now that we've done that, let's start off with the attack box. So the first question is, what is the version of CyberChef found? So let's first go to that website. So Firefox and then CyberChef. As it's kind of hard to see anything, I'm going to view in full screen, which will open up in a new tab. So if you look on the URL, we actually can see the version number here, which is 9.49.0. So 9.49.0, can submit that. How many recipes will you use to extract URLs from the malicious document? So if we want, we can go through here and count all the ones which are added. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 recipes were used to extract and defang the URLs that were contained in the malicious document. Okay, so we found a URL that was downloading a suspicious file. What is the name of the malware? Well, so it seems like I'm actually going to have to go through and run all the recipes, so let me do that quickly. Okay, so we're finally done. I thought that would be quick to do, but because of how laggy the attack box is, that took me about 15 minutes to do. So let's go on the questions. So we found a URL that was downloading a suspicious file. What is the name of that malware? So that is called mysterygift.exe. What is the last defanged URL of the Bandit Yeti domain found in the last step? That is this one, if I can copy it. And then we can paste that in here. Submit. So what is the ticket found in one of the domains? Format, domain/golden flag. THM mystery flag. There we go. So if you're wanting to do more things like this, there is a room for security information and event management. And that is day 7 of Advent of Cyber completed. If you like this video, make sure to like and subscribe to see more videos for Advent of Cyber 2022.